maximization numerical. So maximize z is equal to thrice of x1 minus x2 subject to subject to 2x1 plus x2 less than or equal to 2, x1 plus 3x2 greater than or equal to 3, x2 less than or equal to 4, and x1 comma x2 greater than or equal to 0. So this is the numerical that they have given us, right? So here you can see there is inequality sign of less than or equal to, sign of greater than or equal to, again it is less than or equal to. So how to frame out this particular thing that we are going to see. So initially it is a standard simplex problem. So sorry, it is a standard LP problem. Let's frame out the simplex problem. Frame simplex problem, right? So here now that you should understand that this numerical do not have less than or equal to sign, no, continuously. Here we have greater than or equal to sign also, right? So if it would have been all the less than or equal to sign, like the numericals that we have seen before big M problem, so simple simplex technique was also sufficient. But now here we have the mixture of less than or equal to and greater than or equal to sign, and hence we'll have to particularly think of something else, and that we have chosen big M problem, right? So here let's start with framing the simplex problem. So here we have maximize z is equal to thrice of x1 minus x2 subject to so here it is less than or equal to. So when there is a less than or equal to sign, what is to be done? Yeah, and even if you can recall, if there is greater than or equal to sign, so what we'll have to do is we'll be adding the adding the slack variables only. So it will be twice of x1 plus x2 plus s1 is equal to 2. Do we need to add any artificial variable here? No, because it do not consist of greater than or equal to sign. So there is no need of adding the artificial variable, right? Similarly, let's move with another constant. Here we have greater than or equal to sign. So x1 plus thrice x2. We are going to consider the slack variable, but it will have the negative sign. So minus s2. But here we have to add the slack variable plus a1 is equal to 3. Right now again we have x2 less than or equal to 4, so x2 plus s3 is equal to 4, right? So now we can write x1 comma x2 comma s1 comma s2 comma s3 comma a1 should be greater than or equal to 0, right? So in the chat section you can tell me if you have understood how we have framed out our objective function. Can be completed. It will be 0s1 plus 0s2 plus 0s3. Now it is a maximization problem, so here you will be having a minus sign, so minus ma1, right? In the chat section you can tell me if you have understood the framing of this particular type of numerical, and then we can try to solve it ahead. You can tell me in the chat section, please. Yeah, many of you are telling that you have understood there's how the framing is to be done. So let's move ahead and uh, frame out this simplex table, right? Frame initial simplex table. We have 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. So what is here? It is x1, x2, s1, s2, s3, and a1, right? So the coefficient of these variables in the objective function are 3, -1, 0, 0, 0, and it is minus m here. So here it is solution. Now tell me how many variables, basic variables, we'll have to consider. As there are three constraints, we'll have to consider three basic variables. So three basic constraints. Sorry, three constraints. So three basic variables. Very important. Right? So here, which variables are to be considered from each constraint, that we are going to see. Right? So from first constraint, there is no artificial variable. So only slack variable will be considered. In your second constraint, you have both slack variable and artificial variable, but the preference is given to be given with to which? It is to be given for artificial variable. And lastly, we have only the slack variable, and hence we'll be writing it as S3. So here it will be 0, 0, and for A1 it will be minus m sign that will be taken into consider. So let's represent our constants in this tabular format. So it will be 2, 1, 1, 0, 0, 0. The solution will be 2. Similarly, it will be 1, 3, 0, -1, 0, 1, and it will be 3. Right? For S3, it will be 0, 1. It will be 0, 0. Right? S3 will be 1, and here it will be 0, and it will be equal to 4. Right? So I'm hoping that you have understood this, how we have written this. So next very important step is Zj. We are going to find out Zj minus Cj. Right? So here it will be minus m. Next label 0. It will be minus 3m. Right, so it will be 0, 0, 0 only here. It will be m here. It will be 0, 0, 0 only. It will be minus m here, and it will be minus 3m here. Right, so what we can have to do is Zj minus Cj. So 3 minus minus m will be 3 plus m. It will be minus m minus 3m will be what? Minus 1 plus 3m. That is 0 minus 0 is 0. That is 0 minus minus m will be minus m. It will be 0 minus 0 is 0. Minus m plus, sorry, minus m minus minus m will be m minus m plus m will be equal to 0. Right? So here what we'll have to do, here it is which problem? It is maximization problem. And for maximization problem, all Cj minus Zj values should be greater than or equal to all Cj minus Zj values should be less than or equal to 0. So we'll have to check 3 plus m. If we consider m as 1000, so it will be 1003, right? Minus 1 plus 3m. So minus 1, if we consider this as 1000, so it will be 2999, right? So even with these two values, we can say that this is not a this is not an optimal solution. And now, as this is a maximization solution, so I'll be writing here 3 plus m. What is 3 plus m? If we consider m value as to be 1000, so it will be 1003, right? So if it is minus 1 plus 3m, it will be C minus 1 plus 3m, that will be equal to 2999, right? So amongst this, which is the maximum value? Here it is maximization problem, right? So this is the maximum value, and hence this will be what it will be your entering variable, and this will be your key column, right? So now we'll have to identify the key row, so that needs a ratio value. So now you can go with 2 divided by 1 is 2, 3 divided by 3 is 1, and 4 divided by 1 is 4. So the strategy for identification of key row remains same for all the type of numericals. Can be a maximization or minimization, but here we'll have to select smallest non-negative value for the key row identification. So this is this is 1 will be the value, and it is your key row, right? So now with this, what we'll have to do is we'll have to move ahead with framing the new no, new values, right? So just give me a second. I'll be writing the next iteration table only. I won't be repeating this particular again because look, that will be again a waste of time, right? So I'll be writing the new iteration values again, and then for the last step we can take this into consideration, the no, how to take the new values, right? So I found it at my level, so it is CB. So this is a solution. X1, what we have is, it is 3 minus 1, 0, 0, 0, and minus m. So I'll be writing all the new values here. If you remember from the last table, our entering variable was, what was our entering variable? It was x2, and the leaving variable was a1. So s1, S3, x2 was our entering variable, so x2 has a coefficient of -1. This is 0, 0 at this stage. The new values for all the cells is this I'm writing 0, 1, 0, 1, 0, 0, 1 by 3, minus 1 by 3, then it is 1 by 3, it is 0, 0, 0. Artificial variable has already been gone from here, so you cannot consider, you can skip this and you can save the time. So 3 by 5, 3, and it was minus 9. So if you find out the zj values and cj minus zj values, so that I'll be writing here, it comes out to be minus 1 by 3. So here it will be coming out to be minus 1. Here it comes out to be 0. Here 1 by 3. Here it is 0. And here it is minus 1. Cj minus zj values 10 by 3, 0, 0, minus 1 by 3, and here it is 0. So if you check, all Cj minus Zj values are not less than or equal to 0. So hence we'll have to iterate further. So there is only one positive value here, which is 10 by 3. And the 10 by 3 will be acting as our key column. So I'll be marking this column as a key column. We'll have to add one more column, that is of ratio. Ratio will help us to find out the key row, right? So here we have this value as 3 by 5. Here, sorry, the solution values were 1, 1. Sorry, I made a mistake. So the solution values were 1, it is 1, and it is 3, and all these were the ratio values. So 3 by 5, 3, and minus 9 are your ratio values. So according to this, 3 by 5 is the smallest value, and this acts as your no leaving variable, right? So this row will be what? This row will be your key row, right? So let's move ahead for our last iteration, CB. Here it is CJ, basic variables. It is 1, 2, 3, 4, 5, 6, 7. It is x1, x2, s1, s2, s3, a1, and this is solution directly. It is 3 minus 1, 0, 0, 0. Here it is minus m value, right? Now that we have got x1 as an entering variable and s1 as a leaving variable, so that needs to be represented appropriately, right? So our entering variable is x1, right? Then we have x2 here and s3 here. X1 has a coefficient of 3, x2 has a coefficient of -1, and s3 has a coefficient of 0. So all the new values that I have found out, I'll be writing here. You, as on your side particularly, can check all these values and uh, understand this numerical, right? So here a1 do not play any role. So here the solution value is 3 by 5. Here it is 0 1 minus 1 by 5. Here it is minus 2 by 5, and you have 0 and 4 by 5 here. Next it will be 0 0 1 by 5, 2 by 5, 1, and then we'll have 16 by 5. So here again Zj and Cj minus Zj can be calculated. It is 3 minus 1, 2, 1, 0, and here 1. And you have 0, 0, minus 2, minus 1, and 0 here. So if you see, all Cj minus Zj values are either 0 or less than equal to 0. Hence, we have got the optimal solution. So if you have to write the answer, so x1 value will be equal to what? X1 value is equal to 3 by 5, right? So here x2 value is equal to 4 by 5, right? And no, we do not have any x3 value or something like that. We have zmax value, which is equal to 1, right? It is equal to 1. So all this is your final answer, and your final answer will be considered for your giving of the marks.